we are going to use our congruency rules to do some proofs proving that triangles are congruent. So let's remind ourselves of our 4 congruency rules. We have side, side, side. We have side, angle, side. We have angle, angle, side. And our final one is right angle, hypotenuse, side. So we've got those 4 rules. Every single time we do a congruency proof, we have to prove if 2 triangles are the same, they must at least tick one of these boxes here. Okay, let's do our first pair. So our first pair, we can see we've got a side with 12. We've got a side with a dash, and then we've got an angle in here. On this second one, we've got an angle, a 12-meter side, and one with a dash as well. Let's start by labeling them so we can do this accurately. So let's go A, B, C, and then D, E, F. Okay. So the first thing we have to do is actually decide which are our corresponding sides and angles. So let's have a look. If our triangle, our first triangle is A, B, C, A, B, C, we've got side A and B, and that actually corresponds to F, D. We have to make sure we go in the right order. So side A, B corresponds to F, D, and it is, we're not sure how big it is, it just has a dash, but we know that they're the same, okay, and they are equal. So we can actually say A, B is equal to FD. Next, we have another side. It is 12 meters. Let's call it AC. It corresponds to FE, and we can see that they equal 12 meters. So this time AC is equal to FE, and that is 12 meters. And this is a side, and this is also a side. So we could potentially do any of these right now, but we need to know about the angles. We do have an angle given here. So that angle, let's have a look, it is angle BAC, so angle BAC, and it corresponds to angle DFE. And we can see they are both 80 degrees. So angle BAC is equal to angle DFE, which is 80 degrees. And now we have an angle. So we actually have side, side, and angle, but to make sure that that fits side, angle, side, it must be the included angle. It must be the angle in between the 2 sides. So let's have a look. Here's the side, here's another side we know, and the angle's in between. So that one's actually okay. This means we can say triangle ABC is congruent to, have a look at that symbol. You might also see it written is congruent to with a squiggle on top, and that's perfectly okay. We're trying to say triangle ABC is the same as triangle FDE in this case, okay, because of side, angle, side. That's the kind of working you should see every time you are doing a congruency proof. So let's have a look at our second pair, and we're going to go much faster this time. We've got A, B, C, we've got D, E, F. Let's have a look at our corresponding sides. We know some information about this one. It's got the double dashes, and it actually matches up here to this side. So BC is equal to DE, sides, and that is side, so we can write S. We've got an angle. Let's go angle ABC is equal to angle FDE, and that is an actual angle, but it's a right angle. And then we've got another side here, and this one here is actually across from the right angle, which makes it the hypotenuse, so that's important as well. Let's write that down straight away. It's the hypotenuse, and we are going to say side E, or let's go first of all CA is equal to EF. We don't know their sizes, but we know they're the same. Oh, I haven't done that right at all. I'm very, very sorry. That should be there. That's terrible of me. Cross this out. Okay, so now we can prove that we have a side, we have a right angle and we have a hypotenuse. If we look over here, we have the right angle hypotenuse side, so therefore we can say triangle ABC is congruent to triangle FDE because of right angle hypotenuse side. Okay, apart from my silly mistake there, I've got to work on rotating my shapes. That is how we do a congruency proof.